Good morning everyone. I am Tanushree Dalai from Civil Engineering branch, and today I am going to teach you your Theory 1 paper, which name is Structural Mechanics. In the last class we discussed about the shear force and bending moment calculation of cantilever beam with point load and uniformly distributed load. And today we will learn about the shear force and bending moment calculation of a simply supported beam with a point load at the midspan of the beam. So here is your derivation part. So you can see here is a beam which is simply supported at the two ends, which is A and B, and at the midspan of the beam a point load is acting, which is W kilonewton. The total length of the beam is L, and half of the length from the midspan to the end of the beam is L by 2. So in case of simply supported beam, first of all we need to calculate the reaction calculation. That means reaction at the both end of the beam. That means reaction at A is denoted as RA and reaction at B is denoted as RB. So, according to the equilibrium condition, we know that the total force acting in a beam, which is the total downward force, will be equal to the total upward forces. So in this section, the reaction at the both end are acting as the reaction at A and reaction at B as the upward forces, which equal to the total downward forces. So the downward forces is here W kilonewton. So we can say that RA plus RB is equal to W. So in case of reaction calculation, first of all, the total upward forces, that is RA plus RB, is equal to total downward forces, which is W. After that, we need to know the value of RA and RB. So for that, we need to taking moment about any end of the section as 0. So in this section, we are taking the moment about A is 0. So at point A, what are the moment for this point load and this reaction we will calculate here. So now, first of all, if we are taking the moment about A, first of all we need to see at the right side of the section, and what are the forces here? First of all, here one reaction is there, and second one is here one point load is there. So we have to calculate the moment for this reaction and this point load about this point A. So first of all, we need to calculate this reaction at B. So the moment for this reaction up to this point will be load into distance. The formula for the moment calculation for point load is load into distance. So for this reaction, the load is RA and the distance up to the A point will be L. So that the RB into L will be the moment for this reaction to the point A. Hence RB into L, and the sign of the moment calculation of this reaction will be positive because this reaction gives a sagging moment towards the point A. Then the second load is W. So for the W, it will give a hogging moment towards the A. So the load is W and the distance from this point to A will be L by 2. So the moment calculation will be W into L by 2, which equal to 0. So from this we can calculate the RB value, which we got W by 2. So we know that RA plus RB equal to W, and now we got the value of RB as W by 2. Hence, the RA value will be W minus W by 2, which equal to W by 2. So now we got the value of two reactions, that is RA and RB, as W by 2. So now we can calculate the shear force of the salient point on the beams. So first of all, we have to subdivide the whole span of the beam into two sections. First of all is from A to C, and next section is from C to B. So in case of span AC, we have to calculate the shear force at point A and then the shear force at point C. Similarly, for the second section, that means from the C to B, we need to calculate the shear force at point C, and next is the shear force at point B. So, we know that in case of span AC, first of all, the shear force at A point is equal to the forces acting on the A. So in case of this point, that is point A, the shear force is in terms of reaction, which we know that the RA value is W by 2, which we already got from the reaction calculation. So we can put the RA value in the place of shear force at point A. So shear force at point A is equal to RA, which is W by 2. Then next is your, at span AC, the value of shear force at C. So you can see in the AC span from A to C, any kind of loading is not acting. So that we can say the shear force at point A will be continuing towards the point C. Hence, the shear force at C also W by 2 due to no loading in between A to C. So now comes to the next half of the span, that is span BC or span CB. So here first of all we need to calculate shear force at point C. So you know that at point C there will be a point load. So that's why from the span AC, the shear force we got at point C, we put here and then deduct the value of point load from this. Because in case of span CB, if we draw a section here, then the loading system is at the left side of the section and in downward in direction. So according to the shear force sign, the W value will be negative. So that W by 2 minus W will be give the value of shear force at C, which is minus W by 2. And now the shear force at point B will be also minus W by 2, because in between C and B any kinds of load is not acting. So that's why the value of shear force at point B is similar to the shear force at point C, because the shear force at point C is continuing towards the point shear force at point B. So now comes to the bending moment calculation. So we know that in case of simply supported beam, at the end of the span, that means at point A, and at point B, that means where the supports is acting, that points are zero bending moment. So that we can say the bending moment at point A is 0 and bending moment at point B is also 0, because here only load is acting or forces is acting, but there is no distances. So for the calculation of bending moment, we need load into distance. So here, due to no distance and only force, the value of bending moment is 0. So now, bending moment at point C, that means at the mid-span of the beam. So, first of all, the bending moment at this point, we need to see at the left side of the section, and what are the forces acting here, we need to know. So first of all, here is one reaction which is RA, so that only one loading condition is there. So by calculating the bending moment at point C, we need to multiply this loading condition into the distance between here to here, then we can get the value of bending moment at point C. So the RA value is W by 2 and the distance between A to C is L by 2. So the load into distance will be W by 2 multiplied by L by 2. Hence, the total value will be WL by 4. And the positive value due to the sagging moment. That means this value or this forces is giving a sagging moment towards the point C, so that the value is positive. So now we can draw the shear force and bending moment diagram according to these values. So in case of shear force diagram, first of all, shear force at point A is W by 2. So first of all, to calculate or to draw the shear force diagram, we need to draw a reference line here. And then at point A, we got the value W by 2. So we can give a point here. And then at point C, it will be continuing. So here is also W by 2 for span AC. Next is for span CB, the value of C is minus W by 2. So the point will be occur here. And then for the B, the value of the shear force will be minus W by 2. So the point will be occur here. So by joining all these things, we can get the value of shear force. So now, for the bending moment diagram, at the point A and B is 0 bending moment. So here will be a point and here will be a point. And the maximum bending moment will occur at the center part of the beam, which is at point C. The value is WL by 4. So here is the shear force and bending moment calculation for the simply supported beam having point load. So today this much. Thank you.